Hello folks, so today I'm going to be doing a coding challenge on LeetCode. Actually, I was on a technical interview recently where I was asked a similar question, and I kind of wanted to review that for myself, but also for anyone else who was curious about this, because I have been having difficulties in the past working with combinations. So given two integers n and k, return all possible combinations of k numbers out of 1, as in 1 all the way up to n. For example, if n is 4, you're basically looking at, you can imagine a list of numbers 1, 2, 3, 4, and that's your list, with k of 2. So this is akin to a kind of standard n choose k problem. And because it's combinations, the order doesn't matter. So for example, so we have 1 and 2, 1 and 3, 1 and 4, and then 2 and 3, 2 and 4, and then finally 3 and 4. And 3 and 4 and 4 and 3 are the same thing, so you don't need to repeat that. If this was a permutation, then the order would matter, and that would be a different setup. But here the combination is a challenge. So I'll let you all get a second. I'll have the link in the description, of course, so you can all try it out on your own, and I'll go over my solution afterwards. Okay, so I first want to go over the logic of how would you even do this in person, manually, and then kind of go over how I'm basically going to recreate that process in code. So we are given an example of n equal 4, and that effectively is like a list of 4, 1, 2, 3, 4. So k of 2. So we're choosing 2 out of these 4 options. So first things I do is I loop the 1 and 2 together, and then I'd say, okay, so that's 1, 2. It's a weird 2. Then I'd go, okay, knock the 2 out, and then go to the next one, 1, 3. And then go to 1, 4. And that's me being done with 1. So then I would go to the 2 and say, okay, 2, go from 2 onward. So 2, 3. Then I'd bump the 3 out and go 2, 4. Then I'm at the end of my list. Then I go back to 2, and I say, okay, increment 2 by 1, go to 3, 3, 4. And at that point, I'm done. And so that's how I would go about creating it. So here we're going to be, again, same situation, but now k is 3. What do I do here? Well, I'm going to grab the first 3 as my first set. Then I'm going to knock the last one off and then go to 4. So I'm going to increment it. Once I hit the tail end of my 4, I go back 1, and then I go back to the 2, and I say, okay, I'm going to increment that to 3. So that's 1, 3. And then, from 3, you go to 4. And you're probably kind of done there. So then I go back all the way to the 1. And I say, okay, 1 is being knocked out. We're going to make that a 2, 3, 4. And at that point, you can't, there's no real room because the 4 is the most it can be. So that is how I would go about it. And we're going to code this out now. All right, so in LeetCode, apparently they give you they require you to have a class that is the solution, and they will call the method from that class. So that's why this function definition looks a little weird, is because it's actually a method in Python. But for the most part, you can kind of ignore this self-reference. We can just say this is combine n and k, because that's how it will be called. Okay, so here I'm going to have my output as my final output list. So that will be what is returned in the end. My stack, and that's going to be my stack that is of k length that I'm currently looking at. So that could be the 1, 2, or 1, 2, 3. It's whatever that is. This I is referring to what is currently being focused on. And so that is basically going to be whatever the tail end is. It's whatever that number is the current I being considered. So we'll see how that will work out later. This length is referring to the length of the stack, actually. So currently it starts out at 0. So it's sort of a little redundant to have the length separated here, but you can always just call length on the stack and get the length that way. But we're going to be using length more than once here, so I thought it would be useful to just abstract it into its own way and keep track of it manually, because it's kind of easy to do that. Here we have a continuous while loop, so it's always going to be true. So that's a problem, but we have a stopping condition here in this return statement. So we do stop it, but it's internal in the while loop. And that's actually the whole thing. Everything is going to exist within the while loop after this point. There's nothing else after it. This whole while loop is the logic. Okay, so the first thing you're checking to see is the current length of the stack, if it equals k. Because if it equals k, that means that you've constructed something that is a valid combination, and so you want to add that to the output, and that's what we're doing here. But we are mindful that we're not adding the actual current stack because it is an object reference that we want to kind of keep working with. So we want to just make a kind of copy, and that's what this is doing here. This is just another way in Python to make a quick copy. Okay, so once that is done, you've added it. There are basically like 3 situations that will occur. One, you've had this situation where you've added to the output, and the length is equal to k. Or you've kind of run out of options, in which case I has been incremented so far that it has gone beyond n, and so you're basically done. Or and the other option is like the stack is not at length k yet, so you need to add to it. And so that's what this else statement will be doing. And so we'll look more into that. But first, I'll just go through this stopping statement. So here we're checking if the length is equal to k. So that's the same logic up here. So basically, you're done with one combination, or I has been incremented so far that it's gone beyond the bounds of n, in which case we want to stop. So here, if length is equal to 3, there's a few options that you can do here. The logic can be kind of you can use this as the same logic as the same thing here. The rationale here is basically saying that you have no more options left. However you want to express that goes in here, and that's when you say return output. Once you have, if you pass that means that you must be in the situation where length is equal to k. And so we're going to do this idea of what's called backtracking. So what we're going to do is we're going to remove the last element of the stack. Because again, that's how we were kind of working with it here. We pop the last thing off, and then increment it. So we went from 3 to 4, and then in this step we kind of removed everything until we got back to the 2, and removed the 2, incremented it by 1, and got to 3. And so that's how we're going to keep track of things. And so that's what this pop is doing, and then we're adding 1. That's the increment. So we're changing our focus number by 1, and we can also keep track of the length by subtracting 1 there as well. So this is another step to just keep track of the length. Else, and this else is when we don't have enough elements in the stack currently, and that's when we just append to it. So we're going to add I, and then we're going to increment on I. So that's like going from 2 to 3. So this is like where we would go from 2 to 3 here. Let me go back here. So if we went at the very end here, we pop it off and go from 2 to 3, and then we'd only have a 1 and a 3 in our stack, and then we'd want to add 1 more, and so that would be adding I and then incrementing it. And of course we increase our length as well, so we're always keeping track of the length in that way. And doing this will eventually put us in a situation where we're going to be adding 1 element at a time. So the first time this loop will run, we'll get a 1 in our stack, then a 2, and again that looks like this here. That's this part here. So we append 1. It increments I, it goes back, the length isn't correct, it goes down here, it appends 2, increments I, and it goes back, and then we'll be adding 3 here. So that'll be a 1, 2, 3, that's this combination. We will now have a stack of 3, so this will execute, we'll add it to our output. This checks out here, so our length is equal to k. So then we don't follow this doesn't happen, and then we pop off the 3, and then add 1 to it, which will give us a 4. And then we now have a I of 4. The stack is still length 2, which is a 1 and a 2. And then we loop back up, and this is not true, this is not true, this occurs. We're appending 4 now, and incrementing by 1 to the I. But now we have a 1, 2, 4, which is our second implementation here. All right, so let's check this thing out and see how well it runs. Run code. Okay, so that accepted some. I'm going to submit again. Okay, so it looks like here. So you can see my issues here. My submissions ran. I did fail. My wrong answers 2 days ago were not so great. You can also modify this combination stuff to work with all combinations, and by that I mean things that are length of k that are less than k. So you can modify that as well. So depending on what the problem is, you can change this up. But I definitely found this to be, and I did have to look at the discussion for this for sure. I did not come up with this on my own. I was having a real hard time figuring this one out. But again, the discussion really helped me on this one, and so I found a solution. I forgot who it was from. This one, AC by Diet Pepsi. So this one, I definitely took inspiration from their solution, and this is what they have as well. And there's another thing that's kind of interesting. They had this piece of code. So what was interesting is that they included this little bit of logic here that actually shortens the runtime. So I'm actually going to implement it in my solution just to show you maybe how much quicker it will be. Okay, so here I'm going to modify this a little bit. It's going to be n minus k plus the length plus 1. Okay, and so we're going to submit that and see how much faster that one executes. Okay, so it came faster than 86%. So this one was, you see how it ran faster? The runtime is a little bit faster. What's the rationale behind that? Yeah, and so when you have these situations here where you have the like near the tail end, where you have the 3, 4, 5, and you remove the 5, then you remove the 4, then you remove the 3, it's going to try 4 next. But there's no possibility beyond, 3, 4, 5, because that's the tail end basically. So the current code that I had before was allowing the loop to continue checking 4, 5, and then 5 by itself, and that's a little excessive. And so this little bit of added logic here, you're not checking anything that does not need to be checked. Okay, so that is it for today. If this is the kind of stuff that interests you, please be sure to like, subscribe, and all the good things, and I will see you next time. Take care.